Yeah, my name is Nicolas Brousse. I'm a Senior Director of Operation Engineering. So basically, I deal with what breaks on the platform and try to fix it and make sure it doesn't break anymore. I joined TubeMogul in 2008 and make me move from France, so hopefully you will pardon my French. At that time, we were about 7 people. We are now about like 500 plus people. The engineering team is about 130 people. So there has been a lot going on in 8 years. We went IPO last year, which has been another challenge too. I will try to cover how we handle this growth and what are some of the key things we do to manage our operation and how we make sure the system stay up and alive. So TubeMogul is what we call an enterprise software company for digital branding. To make it simpler, we do all the video advertisement things, so all the annoying stuff you see on, if you go on CNN or YouTube before the video you want to see, you see an ad and it's annoying. It's not ours. The one you will see is the one that has been properly targeted and you like it. That's the idea. There is all this auction system on the video advertising world. It's like a stock exchange, but for video ads. And that's why we end up having to deal with so much traffic and so much volume. Last year, we served about 27 billion ads, which was managed with like 30 billion ad auction a day. That explains the large volume of traffic we are seeing. The bid processing need to happen in less than 50 milliseconds. When you are going on your news site or on YouTube or whatever, you don't want to wait more than necessary to see an ad. So this process has to be in real time, very fast. That makes it challenging, but also very interesting in an engineering point of view. At the end, the bid need to be served for most partner and most integration in less than 80 milliseconds, which includes the network contract. That creates some challenge based on location and things like that. We serve directly about like 5 petabytes of video traffic. Most of our video ads are not served directly by us. That will be by some other partners or whoever the advertiser want to use. The operation engineering team is in charge of the smooth day-to-day operation. I'm sure you're all familiar with what that means. We try to provide a cost-effective and cutting-edge infrastructure. Keep in mind that TubeMogul was a very small startup. We are growing fast. Even if we went IPO last year, we are still working at making a successful business. We are competing with big companies. The advertising market is challenging. So we are trying to be efficient at all levels. The team is mostly composed of SREs, SEs, and DBA. And we currently manage over like 2,500 servers. Most of them are virtual, mostly on Amazon. We start to have more and more on physical. I will get to this a bit later. We have multiple locations. That's great. It's also sometimes part of the challenge, trying to monitor and track all this and manage provisioning. Most of our operation team is currently in US and in Ukraine, but we have to manage all this location. We use public cloud in 6 regions right now, including China, and we have 2 locations on-premise in US. We are a big technology hoarders, mostly because of 7-8 years of a startup world, I will say. And because we're also in the Bay Area, I'm guessing there is all this trend of always using the latest fancy technology. It makes it an interesting challenge for operation, but it also makes it very hard because you need to become an expert on many technology, which is almost unrealistic. But it's very interesting to manage. So we have like a lot of different HTTP front. We have a lot of different caching system, database, lot of big Java infrastructure. So all our team need to become like expert at troubleshooting JVM and Java application, things like that. And we use a lot Amazon services from DynamoDB, EC2, S3, and stuff like that. So what does it look at a high-level view? We have like, I will say like different three key different points on the infrastructure. So the first part is all the bidding layer. That's a slide. On the left, you will see we have eyeball traffic. So that's everything that comes from browser, mobile, all the desktop, tablets, all these things. And we have also what we call server-to-server integration, SSP. So that will be people like Google, Yahoo, LiveRail Turn. So LiveRail is Facebook now. That will send us a bid request directly. It's a direct server-to-server integration. We don't have to be close to the end user. And it's more and more what the industry is going through. But so we have to manage this different kind of traffic. It goes through a bidding layer, which need to make the auction decision very quickly. So it has to access to a user database to make efficient targeting decision, but also to find like which ad and which campaign is active, things like that. Then there is a second part that is also a lot of eyeball traffic. Most of it is eyeball traffic. That's when we serve the ad. That's when we serve the tag and things like that. That's our clients access their console and their metrics through the web UI. That's also how we collect pixels. In the ad industry, most of the tracking is done like through pixel collection. It's start to change, and there is new technology trying to be found, especially because of like all the legislation around like cookies and things like that. But right now, as of today, the biggest way of tracking stats and viewability and things like that. And the ad servers, for most of them, will provide like the tags or the ads that need to be delivered, but in some cases there is all these proxy solutions that goes to a third-party ad server, which can be a big challenge because you end up having to rely on your system on another third party that may introduce like big latency. So it's become an interesting challenge too. And all that need to be connected to a real-time loop that will inform the system about like cache updates or any change on your campaign and things like that. So if a client wants to stop his campaign because he don't want to spend more money, this needs to happen very quickly. We can't wait like 6 hours and spend like another like $10,000 on the campaign. We need to be able to have a full system that react very quickly. Including for the stat, we need to be able to collect like the spend on those ads fairly quickly. Then there is a third part that is more offline, which is another part of user targeting and data collection, where we try to centralize from different provider information about people, so we can do efficient targeting, know if it's a male or female, if it's like which range of age and things like that. This represents a lot of data, and it's where like most of the machine learning work will happen. That's a very high level of the system, but it should help understand some of the technical challenge we have to deal with. So on the left part, you will see that it's a very high volume traffic with a small packet. It's all the bids, so we get a lot of auction. It's really like a stock exchange things in NASDAQ, where you have a lot of volume every day. Doesn't mean you are going to make an auction on every time. You choose on which stock you want to bid. So that's what we do. So we get a lot of information coming in, and we choose on what is relevant for us and what will be the most cost efficient and relevant for our customer. This needs to happen in low latency. There is all these fast bidding decisions that is necessary on the system, and access to a large data set, over 20 billion entries currently, which need to be also very low latency. Then there is this other part where we have like high spike. We will be very dependent on internet traffic, internet peak and load and things like that, which make it hard to autoscale. You are in the ad industry. If suddenly ESPN or whatever have like a campaign or something that starts on generate a huge spike, you won't have time to easily auto-scale because your ads are already delivered. It's real time. So it's part of the challenge. We are vulnerable to third-party latency. If their system is slow, our system will become probably slow too. This is generally a latency of like 150 milliseconds to serve all these things. We need a safe and fast UI. We must serve absolutely the ads, and we must collect all the pixels. If we miss pixel collections, that means we stop tracking, so we may serve ads that we won't be able to charge to our customers. So it does really mean like a direct impact on the business and revenue. Also, real-time data collection and processing is currently done in less than 5 minutes. There is a big cache change management that happens, so we can propagate in all the system in this, that many servers and location, all the information that need to be propagated. And we also process about 20 terabytes of stat logs every day that are used for billing and all that. This is a process for a Kafka system, Kafka and Storm and all that to keep it real time. And our SLA is less than 15 minutes. So when you have your campaign running, you will see at the maximum, 15 minutes later in the UI, the result of your campaign and how much you spent. In reality, we are closer to the 2 or 3 minutes at this time, but we keep some room before getting paid. The second part is really the same thing. The third part, sorry, is high spike, hard to scale, medium latency. Bigger packet on the data collection, we end up having like sometimes like requests like from 1 or 2K to like 30 meg. So it's become challenging because your front doesn't scale the same way. So we have to be able to identify this traffic and distribute it properly so we can scale efficiently. That's the high level of the challenge. How do we manage all this? So we try to have a very tight day-to-day operation. We use heavily configuration management and automation. We have, I believe, a good process of change management that we tie to code review, peer review, and our continuous integration workflow. We really try to consider our infrastructure, all this trendy word about infrastructure as code. We really try to take this approach and consider the way we manage operation as any other software development challenge. We measure and monitor a lot. So OnCall process, to keep it simple, that's something we have been working. It has always been a challenge. When you are in operation, you end up having to deal with the big project you want to do to stabilize the system, and then you have also like all this interruption every day when there is something breaking or something like that. So over time, we split this to make sure that we can focus on one or the other. We have a good rotation with our team in Ukraine. We are able to do a 24/7 on-call rotation, and we leverage a Kanban process. So it's really a top-down approach on the incident and based on priorities and things like that. This allows us to keep our day-to-day operation very smooth and always not forget about like any server crashing somewhere or some maintenance that need to be done. It allows us to keep this day-to-day smooth, while the rest of the team can focus on a bigger project. Alerting. So we have a very large Nagios installation. It's about 20 Nagios servers distributed globally. We start to introduce Sensu. It's a framework, an alerting and monitoring framework. We start to use it mostly to help us scale better, but also to give more control to our software engineering team on how they can create new alerts and new monitoring. Right now, it's something that is a bit complex with Nagios. it requires them to use our configuration management, change some of the template we use with Nagios, it gets regenerated and all that. Now with Sensu, we are able to integrate that directly in the application and populate directly from there. It gives much more control and kind of fills the gap between dev and ops, but also makes the accountability and responsibility of which part of the system need an alert or not much more easier to manage for software engineering team and ops. We centralize all our alerting through an OnCall dashboard. So it's a simple thing that will just get information from all our Nagios. It will inform us about what is paging, what is critical, what is running, host up and down. We get that also from Sensu. And we integrate all our alerting infrastructure to Google Calendar. So every software engineering team can have their own OnCall. They can be responsible for the software they developed. So we don't necessarily carry the burden of maintaining something that is still bleeding edge. The developer will take responsibility for it. And they will have their multiple tier and all that. So we leverage Google Calendar, plug all our alerting on that, multiple tier, and based on the team, we'll just identify like who need to be paged and who need to be escalated to. Which cloud provider? So we have multiple locations, multiple of challenge, including China and Europe, Asia, US. There is a lot going on. At the end, it doesn't really matter as long as your choice keeps the flexibility, keeps your software engineering team able to work and move quickly. So we currently leverage AWS for many different workloads. We use EC2, DynamoDB, SQS, SES, SN, SRDS, SWF, and I'm sure I missed some. This is one of the flexibilities that our software engineering team love. The workload very varies. We have like ephemeral compute jobs that will be mostly like machine learning workload, but we also have like always-on infrastructure on Amazon. Can be expensive, but there is a lot of flexibility in doing that. It allows us to spin up like new location or process very quickly and understand how the system behave and what needs to be done. We moved part of our low latency dependent workload out of AWS. So I know like most people are doing the other way, moving from on-premise to AWS. Well, in this case, we have been on Amazon for a long time, and we have started to move some of our workload out of Amazon, especially for this low latency, high volume traffic part of the system. The data center proximity was a key to this decision. We needed to be in some locations that Amazon was not necessary. Adding like 10 or 15 millisecond latency to network latency to the bidding process is a lot when you just have like 80 milliseconds. So the location is very important for this part of the system. Performance investigation and tuning, it's another big point. We'll get more into detail. One of the biggest challenges has always been about like CPU steal or packet loss, random performance peak in Amazon. When you have to guarantee the millisecond, we are not in the microsecond like the stock exchange industry, but the millisecond, you need to be able to understand what is impacting your performance, and so you can define like a clear way to fix that. Network visibility, that has been one of the big challenges when we randomly stop having traffic for like 1 or 2 hours in some location, and then just by opening tickets from like partners and then Amazon, you see like traffic coming back, but you don't have a clear answer on what's going on. Especially since we are now a public company, we need to be able to be fully accountable on what we are doing. So understanding what's going on at the network level is very important. If we stop having traffic in one region or in US, we need to know why. We need to be able to explain, come up with solution if there is. Generally, if there is. Business accountability, so that's the same. It's really to be able to guarantee the revenue and be able to be accountable to shareholders and all that. Where we are at with our OpenStack infrastructure, so we leverage OpenStack for in-house solution. So the first part of this slide, you will see like you have like the bare metal servers, there is TubeMogul, and there is like Rackspace, CERN, and all that. That's pretty much where we are at. We are still a small player in the OpenStack world and premise world. We have currently about 200, it's a bit more than 144 nodes, but close to 200 nodes in one location. We only do this OpenStack infrastructure in US West. We are planning to do US East, APAC, and Europe next year as we learn more and get more in control of this infrastructure. It's still a small-scale private cloud solution, but it's enough for what we need. We don't try to be fully compatible Amazon or try to reproduce everything Amazon has. It's really specific to the use case we have, which is like all this bidding process. That's the scary part at the bottom of this slide. How much time it took us to work on that. We started in 2013 with the first dev environment. It went well until like we discover how safe work, which took us a bit more time to go through like some of the hiccup and redesign a little bit what we were doing. Also trying to dedicate people to this work. What we tried to do at one point was to have like SREs that can take care of our platform infrastructure, take care of OnCall, but also work on this private cloud. That's just not realistic. You need to have people dedicated to this effort because there is a lot of work required and you need focus to make it right. Since mid this year, we have been able to serve like all our ad serving traffic in US West with very good result. We divide our workload compared to Amazon by 2, which was a nice improvement. We were not necessarily expecting to see so much improvement, but that was a positive impact. We have switched full production like in late August, early September. And we are still on it with no major issue at this time. And we have been able to reduce our footprint to, I think about like 30% on our bidding process. Yeah, I will not go too much on the number because I'm not sure actually. So some of the challenge I said is latency. Globally. We can't solve everything by going in-house or with Amazon. Some of the challenges like geo-based DNS isn't necessarily based on network performance. So when you need to deliver your pixel to make sure you will be able to charge your client, geo-DNS is not necessarily the best solution. Proximity to the user is very important. So you reduce the latency of like the standard like TCP uncheck, the SSL uncheck, all these things. Mobile networks is a challenge. Most of them behave differently. They will have like a proxy. You will have like some filtering, especially in the video in the video industry. We may be like classify improperly. It's happened in plane if you use like GoGo or Boingo or whatever. Occasionally we'll get like blocked because it's compared to a Netflix or something like that. So there is a couple of stuff there is a couple of challenges here. To have a good latency, you require a very global footprint. You pretty much need to be a CDN, need to be close to the ISP. And having a large footprint, that also means that you probably don't benefit of like TLS session resumption or like leverage a better cache on your system. It makes your infrastructure much more complex. We are still a small operation team. That's something that is a real challenge for us. So how do we ensure that our pixel delivery can be done in 50 milliseconds at the 50th percentile globally? We currently had to find a solution for some specific customer. And we leverage Fastly, which is a CDN provider. So at the top, you will see the standard pixel process. So you have like the browser from anywhere going to our stats infrastructure, the load balancer that is currently in just US East region, and then get collected in your backend service and get to Kafka and get processed. That means from anywhere, you get you have the latency from wherever your end user is coming from. So if you are in Singapore, you will have to go to USES to get the pixel collected. So that means like we have a lot of misses. We drop a lot of information. And especially in US, it's also hard because we'll have like customers that we have like this requirement of 50 milliseconds, but we don't have like data center in Denver, Seattle, Michigan, and we don't have like 15 locations. Yeah. So with Fastly, we are able to leverage them to get this pixel collection async. What's happened is that the browser could contact directly Fastly Edge. We leverage the VCL in Fastly to rebuild the HTTP request, encrypt that in base64, and send that through syslog. Fastly will then, in an asynchronous fashion, send us through syslog on a syslog load balancer where we collect the information, reparse that as a HTTP request, and send that to our standard backend. So we don't change anything on the application, but we just process the syslog as a standard request. And instead of having it in real time, we have it in a couple of seconds. And we also push that to S3 to have like the data for analysis and troubleshooting and things like that. So it's very interesting because that's one use case where we need low latency, but we don't necessarily need real time. And leveraging Fastly and VCL and all that allows us to keep a small infrastructure, small footprint. We don't need to add more complexity in our system and can still answer the business need. So what we plan to do more and more with this system is we really like what we saw and what we are doing with that. We do about 1 billion requests a day with just this system. We want to leverage a solution like that more and more to add a layer of protection for DDoS. For example, we won't have like especially as we move in-house, we won't have like terabyte of bandwidth. We won't have like the capacity to handle DDoS. So how we do that while still solving some of our technical problems and still moving in-house. So there is option and situation where we can leverage CDN for like a first layer of DDoS protection. We can leverage more and more solutions like Fastly with their VCL, which is very powerful. If you're not familiar, VCL is a varnish language that allows you to do like to introduce some language in your varnish cache. We are evaluating a routing solution based on RAM, like CDXIS. I think there is few other providers that do that. So the idea is to, instead of being geo-based, we will start looking at real user metrics to decide on where should be directed the end user. And we are also looking at smarter DNS routing, like NS1, where you can introduce a bunch of metrics from your one system to decide like where to direct user. Mentioned briefly about load balancing. We are currently using HAproxy. It has been one of the biggest challenges we got on Amazon, and probably one of the technical decisions to move in-house to, getting our load balancer a little more in control. We use round robin DNS a lot. It's great. It does a job when you need it. Until you start to have like too many entries in your DNS and have like clients that start to switch to TCP, get their firewall preventing to resolve your DNS entry, things like that. We did have like some very difficult case to troubleshoot and understand until we figure out that it was purely like too many entry in our GeoDNS. So we had to figure out a way to reduce the number of entries to make sure that we have a smaller round robin DNS entries. We have like smaller number of load balancer. Too many load balancer doesn't load balance anymore your traffic on the backend. It just become like randomizing pretty much, but without being necessarily aware of your backend load. Sorry. So by moving in-house, we went in US West from 31 EC2 instance that were C3 to X large in VPC 10 gig network to 2 super micro servers. There are 32 core with 128 gig of RAM. We did work with the HAproxy team to help us tune and adjust our configuration and understand better how the system works. We use bare metal and leverage VLAN to access OpenStack tenant. So we are not making a virtual machine in our OpenStack infrastructure. We are using bare metal. So our in-house cloud is a mix of like bare metal and virtual machine. Managing SSL station is what has been the most consuming for our workload. It does require a lot of CPU and RAM. TLS connection can use up to 64K of RAM. We do CPU pinning to achieve all those results. So we ensure to have like 4 core for a network interrupt. That has been one of the biggest bottleneck. And we have like 28 core for HAproxy. Most of those core are used for TLS. We disable hierarchy balance. We have various sysctl config tuning, the classic one. We use one command frontend for HTTP and HTTPS. We serve the cross-domain XML directly from HAproxy. So it doesn't use any network or load on the backend server. HAproxy can serve the file directly. And we send all log to our EL-key infrastructure, Elasticsearch/stash Kibana infrastructure. It's sent it directly in JSON, so we don't need any parsing or whatever. We have a homemade process in Python called evoc that generates the config and scale our backend. So based on how many backend we had in our cloud, so we had like virtual machine on the system, on the platform. It will automatically detect that using the OpenStack or Amazon API, see which tag, which pool it should be on, and will automatically update the HAproxy config. Graphing and logging as a service. So that's something we are moving to. We have been using a lot of different technology, Ganglia, Graphite, Grafana, and EL-key. We have started all our infrastructure with Ganglia. It was scaling well, but over time we had changed to educate people with web UI. We had issues to get the dashboard we needed. So we progressively introduced Graphite. Graphite is still using the RD from Grafana. It's been discussed a bit earlier. From Ganglia, sorry. What we like with Graphite is that there is a very powerful API. There is a lot of pre-built like features and functions that can be used. So we have all our software team, all our QA team, all the business teams that can dig in the matrix very easily, build a small script to call this API and get the information they need. So we still use Ganglia for the collection, data collection on the RD data collection, but we use Graphite to access those data. One of the problems is that Graphite is still not good for the dashboard, so we use Grafana and plug Grafana to Elasticsearch and Graphite to be able to build quickly like dashboard and be able to see and investigate issues. What we do for all these things, including Elasticsearch, is that we have what we call a management VPC on Amazon. It's a separate tenant on OpenStack, so pretty much the same VPC. And we do a VPC peering or use a classic link with some proxy that send everything to this management VPC. The idea was to be able to have like a big data collection matrix and monitoring infrastructure per region that can be used and shared by all our different applications and platforms. Network visibility. So that's one of the challenges. I talk about example where we lose traffic somewhere and don't know what's going on. So we use more and more Catchpoint to help us understand what is going on and have metrics from multiple places in the world. So we really try to test from all the meaningful locations that we have and we need. We can do very complex tests. It's pretty much like Selenium or something like that. You can do some advanced tests. Most of our tests are still very basic, but they help us to get like a lot of understanding if the problem is like specific to a network provider, if it's specific to our load balancer, if it's a backend issue, we can pass like some headers in the HTTP request that can be used on graph in Catchpoint. So we are able to, in one graph, to see if the performance impact was actually at the network level, at the load balancer level, or at the application level. We also use DIN Internet Intelligence. What's very interesting as we move in-house is that they monitor BGP routes, and you'll get notified in any prefix change in new BGP announcements and things like that. You also get alerts specific to some cloud provider used by your infrastructure. You get specific metrics about BGP, I said it. I mean, there is a lot. You will get like also alerts and information about like general routing issue on internet. So if you start to have complaint in Australia and you see in this tool that there is actually like a network incident or BGP hijacking in Asia, you may start to dig to try to see if your system is impacted by this. It's happened a lot in Asia. But it's very interesting to help answer the business on what is going on and why the system is not able to work. It really helps our operation to understand better like what's going on. We have been using Puppet for 5 years now. From 2008 to 2010, we were like always SVN, bash script, custom template. In 2010, we started to manage about 250 instances with all those bash scripts and started to look at Puppet. 2011, we started with Puppet 0.25, quickly upgraded to 2.7, 400 server, 2 contributor, 2012, 800 server, 4 contributor, and going on. We have about 2,000 servers managed by Puppet at this time and 13 contributor. We introduced our configuration management continuous delivery workflow last year. I will get a little bit more in detail in a few minutes. About 2,000 nodes are managed with one Puppet master. I won't go too much in the detail, so we have enough time. But how we use it, we have like multiple solutions. We use master mode for most cases, but for our OpenStack deployment, we use masterless mode. After the successful provisioning, then we start to have an agent on a Puppet agent running and using the master. But the bare metal provisioning is done masterless. Infrastructure as code. We do code review. We try to do more and more of this. One thing when we talk about code review, especially with our software engineering team, they seem to have a different view of the programs than we do in operation. We don't like having like huge change. We don't like merging like huge branches. It requires like too much effort, too much investment to understand what is going on. We like very small change. So we use Gerrit, which allows us to really enforce like some standard. One thing that makes us confident is that a lot of people use it. It's just a way to manage code review. We still have to know how Git works. We still have to do our job, and we still have to provide like good code review. It's great because with Gerrit we can do like fine-grained permission rules. We plug it to LDAP. We can do code review per commit. We have the stream of events that allow us to. We use Git Bleed, but the stream of events allows us to integrate easily with Jenkins, Jira, HipChat, any tools we want, so we can easily make stats on what is going on, how many people did their own code review instead of leveraging a peer, automate like notification on our shared room, things like that. We currently manage about 600 Git repository, so it does work well. I talk about continuous delivery with our configuration management. What's happened is that when we change any Puppet code or any script anywhere, it will be pushed to Gerrit. You will have Jenkins automatically going, reviewing your code, make sure you follow the standards, that you didn't do any mistake and there is no parse error, so it validates your code. Then we have like a human doing a code review, validating that your change makes sense and understand your change. Then it gets validated. When it gets submitted, it gets automatically pulled by the Puppet master on our infrastructure and get deployed automatically in production, or wherever the environment it is. Last year we did about 10,000 Puppet deployments, so it's about 30 a day, I think, yeah. And about 8,000 application deployment. To manage those jobs, to manage all those projects, we leverage the job DSL, Jenkins job DSL. It allows us to code and automate quickly or building process and delivery process. We integrate with HipChat, which allows us to see what's going on, what is being deployed, what is failing. We also have like some cool tools that are able to be integrated, where we can automatically reboot some server and get ticket updated with some log and information that help our troubleshooting. That's the workflow. I won't go too much in the detail, but I'm happy to answer questions. And I want to thank all the teams that work on that every day because they are making this happen, and that's very cool to work with those guys. That's it.
So I have two questions. Have you looked at Nginx for load balancing? Because I have had no success with high volume from HAproxy. Like, it's very quirky when you get a lot of traffic on it.
So, well, HAproxy is French. So
Oh, okay. So it's like the Renault of the load balancers.
no, really, it just came like it's one of the solutions. We started with that, and it worked. Today, that's a question we have a lot in the team. Is like why we don't use these things. But when we have something working, we don't necessarily look at changing it.
Yeah. I started getting really weird errors when I had more than 15,000-20,000 requests per second per HAproxy instance, and it was like impossible to see what happened.
So right now, like the two load balancer I'm talking about in US West, they are doing about like so it's shared between both of them, but they are like 40% loaded. They do about 400,000 QPS.
Okay. Also, I have for your caps. Are you doing them globally, or is it per region, or how have you partitioned your caps?
Sorry, which?
Your caps database.
Oh, yeah.
Is that globally, or is it partitioned in different regions, or how are you doing the caps replication?
It's not. It's in one region. It's something we are trying to work on. It's definitely the hardest pain we have right now. It's hard because it does require application change. So coordinating operation with 130 engineers is not always easy. There is a lot of legacy, and there is nothing very fancy at this time.
So you haven't solved that problem either. We haven't done that either.
Have you ever encountered issues with Puppet code reviews being insufficient, given that you don't know exactly, what diff is going to change on the box depending on your template or that type of thing, with using a master mode of Puppet versus like we use a masterless mode just because we've run into problems so many times with the code review not matching what actually ends up happening on the box, since you don't have full insight into the actual diff that's going to be generated depending on the template.
So we. Unless I don't understand the question, and we didn't get so many of those such issues, but we did get issues where, because we have this workflow working well, we thought like our change was amazing, and it get code reviewed, and everyone is excited about it, it gets pushed, and then you screw your resolve conf and all your infrastructure. We did get some of that, so we are trying to introduce like safety net and more Jenkins automation on some of this part. We did add a bug at one point with the Puppet Master where it was not applying something. It was something on 2.7 or 2.8, where if you had like multiple environments, it was using the library of one of the wrong environment. We moved away from that, and we are now like moving on Puppet 3.8. So we don't see that anymore.
No, you covered it in the first part with like the result.conf, like things that you're not aware of when they actually hit the box.
Okay.
more questions? I think we have time for one more. No? Thank you, Nico.
Thank you.